This is the second part of lesson 11.5 in the Geometry Big Ideas book. This one is using the formula for density. Density is the amount of matter in an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. Different materials have different densities, so density can be used to distinguish between materials that look similar. For example, table salt and sugar look alike. However, table salt has a density of 2.16 grams per cubic centimeter, while sugar has a density of 1.58 grams per cubic centimeter. So when you actually pick up the same volume of each of those objects, okay, the salt is going to weigh more. You're going to feel more weight than you would with the sugar. So using the formula here, the diagram shows the dimensions of a standard gold bar at Fort Knox. Sorry, mine isn't gold like it is in the book. Gold has a density of 19.3 grams. That's how much it weighs for each 1 cubic centimeter. Okay, so for every 1 cubic centimeter. Now, this isn't to scale, but I'm going to draw one that is to scale. I'm going to draw a cubic centimeter very close to scale for you, so you can see what that looks like. So this is 1 centimeter, 1 centimeter, 1 centimeter, 1 cubic centimeter. And gold, for each 1 cubic centimeter, and you can see my finger here, okay, that's how big that is going to weigh 19.3 grams. That's going to be a heavy little object, probably the heaviest object you've ever picked up for the volume. Gold is very, very dense. Okay? So we want to work this out. Find the mass of a standard gold bar to the nearest gram. So in our formula here, we're actually given the density. Okay, we're given how dense the object is, and we can figure out the volume. And if we know the density and volume, we can figure out the mass. So we're just going to look at the formula, fill in the parts of the formula we know, and end up with one variable. Okay, so first thing we got to do, this is in cubic centimeters. We've got to work the problem in cubic centimeters, so we need to do conversions. Okay, so right here we're going to convert 7 inches to centimeters. So I'm going to put inches on the bottom so that they'll eventually cancel. I'm going to put centimeters on top because that's the unit I'm converting into. And then I worry about the ratio between the two. So in every centimeter, or every inch, excuse me, there's 2.54 centimeters. And I'm going to do that same thing for each one. So inches cancel. My answer will be in centimeters. So I'm going to use these unit multipliers, the same one in each case because we're doing the same thing in each case, in order to convert from inches to centimeters. So just multiply this out. 7 times 2.54 is 17.78 centimeters. 3.625 times 2.54 is 9.2075 centimeters. And then 1.75 times 2.54 is 4.445 centimeters. Now you notice we've worked these out. We've actually rounded them off to the 3rd or 4th decimal here to get as accurate as we need to be. Okay, so now how are we going to find the volume of this object? We're going to take the area of its base, which would be its length times its width. Okay, so we're going to multiply these two numbers together. And then we're going to multiply by the height, area of the base times the height. Okay, and so we're just going to basically multiply all three of them together and come up with a volume. 727.69, and centimeters times centimeters times centimeters is cubic centimeters. So now we can plug that in right here for volume. Our volume is 727.69 cubic centimeters. We don't know the mass, so that's what we're looking for. I'll just use m for our variable. And we do know the density is 19.3 grams per cubic centimeter. So now we're just going to solve and find the mass. And as I multiply both sides of the equation by 727.69 cubic centimeters, so we have cancel here, and then on this side we're going to multiply by 727.69 cubic centimeters. And I want you to notice that the cubic centimeters cancel and our answer comes out in grams. Okay, so the mass is grams per cubic centimeter, the volume is cubic centimeters, but the mass just comes out in grams. So we can just multiply those two together and we can come up with our X number for our mass, and there you have it.